Okay, this first problem is crazy because there's three functions of x here. We have a sine, a cosine, and a sine. Three different functions of x. Now before we were using f of x as our outside function, so this would be your sine. Sine of x is your outside function. And then right inside of f, we have our g function, which in this case is our cosine function. So we have cosine right here of x. And then we need one more function to be inside of our g function, so let's call him the h function. So we have three different functions here. Our h function is going to be sine of x. Now inside of this x, you're going to plug in all of this stuff. Inside of the next x, you would plug in this stuff, and then the last one just has an x. But anyways, some of you guys said yesterday that it's kind of cool when you can identify, it makes it easier for you to see by identifying all the other functions that are inside of each other. But I don't know. This looks kind of obvious to me, but here we go. Let's start out with the outside function. So first we got to take the derivative of the outside function. Derivative of sine is cosine. This one's not negative because he starts with the s. He's not a bad guy. That's just the stupid way I remember it. Okay, and then so on the inside you just plug in everything that's on the inside. So we have cosine. Inside of that we have sine. And then we have that. Okay, so the next one is cosine. So now we have to take the derivative of that, and we're going to multiply that to the derivative of that most outside function. So now to take the derivative of the cosine function, that would be negative sine, and then inside of negative sine, we're going to have, you know, whatever's inside of the cosine. So it's going to be sine x. Okay, and then we have one more. We have the derivative of the last one. So we have to multiply that one. You just keep multiplying it. As you take the derivatives of each inside function, we just keep multiplying it. So the derivative of sine is cosine x. And that's it. That's the derivative of that nasty dude. The question is can we simplify this? And the answer is no. I mean, like, you would want to multiply this and this, because those both have cosine, but they have different things inside of them, so you can't multiply those together. You can't, like, say to the second power for those. Okay? Any questions? All right, so this right here is the derivative of all these functions, how they're inside of each other. And this is the chain rule right here. You take the derivative of the f function with all the stuff inside, then take the derivative of the g function with all the stuff inside, and then finally the h. Make sure you multiply all those derivatives together. Okay, let's look at this one right here. Now this one should be more complicated because we have the quotient rule right here. We're going to have to use the quotient rule because we're dividing two functions of x, and we have a function inside of this function. So when we take the derivative of the numerator, we're going to have to do the chain rule. Oi, very involved here. Okay, so let's first do the quotient rule. Okay, so to take the derivative of this, the quotient rule, it's going to be a really big fraction. On the bottom we have 1 plus x squared, and we have to square that. Right? You just square the denominator for the quotient rule. Okay, now for the top, we're going to have minus here, and then we're going to take the derivative of the top times the bottom, and then we're going to take the derivative of the bottom times the top. So let's first take the derivative of the top and multiply it times the bottom. Okay, first let's just write the bottom out. So 1 plus x squared. Okay, we have to multiply it times the bottom. Now we have to take the derivative of this. But to take the derivative of that, we have to do the chain rule because there's a function of x inside of the function of cosine. Okay, so the derivative of cosine is going to be negative sine. And then inside of there we have 1 over x. Then we have to multiply to that the derivative of 1 over x. And to do that, I'm going to make it not a fraction. What is 1 over x not as a fraction? X to the negative 1. So what's the derivative of x to the negative 1? That would be negative x to the negative 2. How do we get that? We take the 1 and drop it in front, so that's how we get negative 1x. Then we have to take 1 away from the negative 1, which would give me negative 2. Okay, so that's that. So that's the only time we have to use a chain rule. The next one, we have to take the derivative of the bottom and multiply it times the top. I'm going to write the top down first because I don't have to take the derivative of that one. Oops. Be x. and we're going to multiply this times the derivative of the bottom. Derivative of the bottom is quite simple. It's just going to be 2x because the constant goes away when you take the derivative, and here you drop the 2 and then you subtract 1 away from the 2, and so you get 2x. Alright, that is it. I mean, there's ways to make this look smaller, but it's not going to get you very far. Like, there's not going to be an identity or anything like that that would make it eligible to be simplified more. So I'm just going to leave this answer like that. The point is, do you know what the quotient rule is, and do you know what the chain rule is? And look, we can combine them. Alright, that's a good question. I'll answer that. So right here, when I was doing the chain rule, the f of x here, the outside function, would be your cosine. And then the inside function, the g function, would be the 1 over x. So you see right here, when I'm doing the derivative, when I'm doing the chain rule, we have the derivative of the f function first, and then we have the derivative of the inside function. Alright? Okay. Did anybody get to the last one? Shall we do it, or shall we skip it and do some other things? Okay. Okay. I'm going to do it. Calm down. Alright. Now we have to use the chain rule twice here, but they're not related. I'm going to take the derivative of this one, and then I'm going to use a chain rule and everything, and then I'm going to take the derivative of this one and use a chain rule and everything. Okay, now e to the x is actually kind of nice. It goes quite quickly. So first, I'm going to take the derivative of the outside function, which is just like the whole thing. So when I take the derivative of e, it's just the same thing. So it's going to be 4 e to the negative x. And then I have to multiply that times the derivative of negative x. What is the derivative of negative x? Negative 1. Now, for that chain rule that I just did, the f function is e to the negative x. Okay, or just e to the x, and you're plugging in a negative x. But what about that 4, Mr. Patey? The 4 is just multiplying to it. You can actually put that 4 on the outside of f. It doesn't really matter. That 4 is just there, okay? And he doesn't go away because the derivative of e to the x is just e to the x. And then your inside function, your g function, would be negative x. So then you take the derivative of that, which would just be negative 1. Okay, now let's add. Let's do the derivative of this one. The first part, the outside function is just going to be 7e to the negative 2x. But then I'm going to multiply that times the derivative of this. What's the derivative of negative 2x? Negative 2. Okay? So now we have some simplifying to do. Here we can multiply that 4 times the negative 1. So we have negative 4 e to the negative x. And then for the next one, right here, we can multiply negative 2 times the 7. So you have negative 14 e to the negative 2x. Now with e, you do the chain rule because it has the exponent. It has another function of x in the exponent. The function of x is like the negative 2x and the negative x. But there is a shortcut. If you look at it, like look at this one right here. When I take the chain rule of that, do you see what happened? Okay, what's the only thing that changed? The negative on the 4. The 4 became negative. And so now look at this one. What's the thing that changed here? Yeah, you just took that negative 2 and multiplied it times the 7. Okay, so that's a little trick that you can do. You just take the derivative of it in your head and multiply it to the front. You don't actually have to think through the whole chain rule. Like, oh, I got to take the derivative of the outside function and the inside function and then multiply them together. You don't have to think that with e. Really, we just have to do, like, if I was to take the derivative of this, I just go, okay, what's the derivative of the top? And I'm going to multiply it to this whole thing. And that's going to be your answer for e. That's like a, I don't know, a lame-o shortcut, but you'll start using it if you do it enough.